I start this 9th lecture, two things that I want to mention. The first thing is regarding your assignment submission phase 1. We are still in the process of evaluating the makeup answer sheets. So give me some more time, maybe another 2 days, by which I'll be able to collect all your assignments, submissions, and I will prepare the list based on the submissions that has been done by you, and the same will be uploaded on the e-learn portal. That we are clear about the groups that have been formed by you, or if you have made a submission individually, right? So this Excel sheet I should be able to complete and upload it by Tuesday evening or Wednesday morning. As soon as this information is collated, um, will also be generated on the portal. Secondly, the quiz 2 scheduled roughly in the first week of November. So announcement regarding that will also be put on the portal. So these two things are in the pipeline. And currently, I'll also be posting the phase 2 of the assignment. Right, so these three things is what we're going to work on in the next 10 to 15 days in this particular course. Right, coming to the next question that has been posted as to how should we prepare for the comprehensive exam, which is going to be open book. What kind of a paper would be there? So you can largely expect more of case studies to be there. That can be one complete case study, which you have to draw all the required UML diagrams and some associated questions on design patterns. Or it could be multiple small case studies, right? So maybe small case study in which you have to draw a certain set of diagrams, another small case study for a separate set of diagrams, another small case study for design patterns, right? Could be like that, right? But the idea would be that there would be no theoretical question as such, for which you can actually copy the answers directly from the book. Right, this is how an open book paper is designed. So it's more application oriented. So given a case, you are asked to draw the diagrams, etc. Right. So let us move ahead with today's lecture. We are going to continue with the gang of 4 design patterns. So in the previous lecture, we studied 3 design patterns, which were a part of the gang of 4. The first was the factory pattern, then the singleton pattern, and then the adapter pattern. Right? Today we are going to have a look at few more. So I have in store today 4 patterns, and if the time permits, we'll complete all 4. Otherwise, at least 3 we should cover today. One of the also designed to see today is the first. Okay. My voice is breaking. Give me a minute. Is it fine now? Hello? Type in. Now it's okay. I'm over a LAN. Okay. 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 I'll increase the volume also. Request to repeat what I said. So talking about the three things that are there in pipeline for this course. The first thing is that we have to take care of, that I have to take care from my side, is to upload the list of groups that you have created based on the submissions that have been done by you people. So that would be up by, say, Wednesday morning. The second thing is the quiz 2, which is again lined up for November. So I have an announcement regarding that as well. And the last thing is the phase 2 of the assignment. So the first week of November, you will also see the phase 2 of the assignment coming up. These three things. There's open book paper. You need to your open book paper will be based on case studies, right? So you will be given either a single case study or multiple case studies, and you would be asked to draw diagrams and answer questions based on the given case study. Right? This is what we were talking about. Now I will start with the today's session, which is continuing with the gang of 4 patterns. And today we have a structural pattern which we will be discussing, and it's the facade pattern. Right? My voice is not breaking. I've started speaking slowly. I think it would be better. I was very fast. Okay, so I've lowered my speed. Okay, so the facade pattern provides a unified interface to interfaces in a subsystem. Right? So this particular pattern, which is a structural design pattern, part of gang of 4, to provide a unified interface to a set of interfaces in a subsystem, right? So the idea is to find a high-level interface that makes the subsystem easier to use, right? So if there are n number of subsystems which the user is required to access and to interface with, this pattern suggests that you introduce a unified interface use, which in turn interfaces with the rest of the subsystems. Yeah, so it is like a, for example, a travel agent. A travel agent does what? The travel agent helps you or plans the entire trip for you, including hotel booking, right? Booking, cab booking, right? So he's acting like a facade object. You need not yourself first book the tickets, book the flights, then take up the cab booking process, right? So all this is done by a single person with whom you share your details, you share all your requirements with this particular travel agent, right? And he does the entire planning for you. And sharing your travel or trip requirements with the travel agent, right? You tell him the dates for which you are planning the trip, the number of people, the locations, your preferable list of locations, right? And preferable travel times, right? So some people want to travel in the night, some people prefer to travel in the daytime, right? So all this information is what you give to the travel agent, and he does all the booking for you. Right? Obviously, he gives you a set of possible solutions, and then you choose from it. Right? So this kind of a facade pattern wherein this particular person uh, helps you in not accessing every subsystem one by one, but access a single system, right? Which has a unified interface, which in turn accesses the rest of the interfaces. Facade is a structural design pattern. It provides a structural, a small additional structure which is put in on top of the various substructures that are there, so that your process becomes simple. Instead of one person accessing individual subsystems which have different interface, you provide a unified interface with a facade object which you access through the unified interface, and this object further accesses the subsystems. Right? I'll show you the diagrammatic representation for this particular pattern. So it looks something like this, right? So this is my facade object that is created here, and it is responsible for accessing all the subsystems, right? So instead of putting a client here, which has to first access this particular system, then access this particular system, and then access this particular system, and then access this particular system, instead of doing everything one by one, you have a top level structure, a top level system which provides a common interface, takes all the information from the user, and in turn accesses all further subsystems and returns you the result. Right? Okay. Come back to what is the facade object, the facade pattern. What is the problem that this particular pattern aims to solve? So there is a need for a simplified interface to the overall functionality of a complex system. Right? Whenever there is a need for a unified, simplified interface to the functionality of a complex system, this is what overcome by the facade object. Right? Is introduce a facade object that provides a single simplified interface to a more general facilities of a system. So the solution is introduce a common object called a facade object that provides a single simple interface. Right? We'll move to an iteration of the facade pattern and then understand it using that. There's there's a complaint that it's not audible. Let me just take off my mic and I'll plug it again. Give me a second. Okay. Let's move ahead. Consider this example, right? Let's consider an example of a hotel keeper who is responsible for acting as a facade, right, for a five-star hotel which consists of 11 restaurants of different kind of cuisine. So there's a hotel, it's a five-star hotel which has 7 different kinds of restaurants which offer different kind of cuisines, right? A client approaching the hotel tells the hotel keeper about a different type of foods they would like to order, right? Combined choices, the hotel keeper suggests the full list of restaurants they should go for. This analogy is the one that has been derived from the some kind of systems that you find nowadays, which, for example, some sites like Trivago, they help you uh, they provide you information from n number of hotels, so you are not required to visit the site of every hotel and look for the possible choices, right? What you give to the facade object, right? Or in our case, in the example that we are discussing, say for Trivago, you give it the requirements as per your budget, your or dates on which you want to travel, etc. And it does matching for you from all the websites, right? So I can see a lot of examples that are coming in, right? So Swiggy, Foodpanda, etc. So all these are acting like facade objects for us, right? So this is how they help us prevent us from accessing a large number of subsystems, sub-interfaces, right? And they are providing us a unified interface, right? Okay, let's take up a few questions. So there are questions, actually examples. So Swiggy and Foodpanda, Zomato, right? So these are all examples of websites which have actually acted as a facade object, and thus instead of accessing a large number of subsystems, they first-hand information through a unified interface, right? What I have implemented here, a very small kind of an implementation, just to make you feel how a facade object would be implemented, right? So just move to the implementation slide. I think most of you have understood what actually practical scenario, what that the facade pattern aims to solve, right? How does it solve that? So in this particular example, the restaurant that we are discussing about, so there's a common interface which has a method use, right? So this is the main method that all the restaurant is supposed, all different kind of restaurant classes are supposed to implement, right? So we have a Chinese restaurant which implements this particular interface and also provides interface implementation for the get menus method, right? I'm not writing implementation for all the 11 different type of restaurants, right? It would be same, but for two more. So there might be some South Indian restaurant, there might be some North Indian restaurant. Each of these class implements the restaurant method, restaurant interface, right? And the implementation for the get menus method, right? So in the get menus method, each of them create an object of their corresponding menu and return that particular object, right? What does the hotel keeper does? Okay, I'll zoom it a little bit. So hotel keeper, right? What the hotel keeper does, he takes as an input from the person who comes to that hotel the list of food items that they would like to order. That they or if for example they might say that they want to order something like F1, F2, F3, and F4. These may be the food items that they would like to order, We don't know what kind of food it is, right? So it might be Chinese, one would be South Indian, something would be North Indian, something would be another Chinese, or something like that, right? So based on this, we would list from the customer. Now it is the responsibility of the hotel keeper to tell the customer that which is the best hotel that you, which is the best restaurant that you should go to. So there might be a possibility that hotel keeper finds a restaurant which offers all these four foods, right? If that is not the case, then he would for the restaurant which has the highest subset. And he would tell the customer that these are the items or F4, and this is they do not offer. Right? Based on this particular the list of restaurants is generated and given to the customer. That's up to the customer which restaurant they would choose for, right? So they might be able to find a restaurant which offers all the four types of food that they're looking for. They would go for that, right? There might be a case that they may find any number of restaurant which offers the four foods, right? In that case, they might look for the budget, right? So they get the pricing and then see that which one is the best suited. Or be a case that they are not able to find a restaurant which offers all the four foods. So the restaurant, say R1, which is offering three of them, and say for example F2. Comes to the customer, they choose that okay, we will adjust with F1 instead of F2, and we would go to this particular restaurant. Right? So this is how the hotel keeper acts as a facade object and gains the information from the individual restaurants, do a unified, do a calculation of this and generates the result, right? A quick look at what the hotel keeper might look like. So, keeper might have a method which says get the Chinese menu, right? So he might create an object Chinese restaurant and request to get the Chinese menu, right? Similarly, he gets the South Indian menu and also gets the North Indian menu, right? And the implementation for the rest of it, but I hope you can understand it. So the hotel keeper has methods which take the food items as the list and return the required menus to the customer. So hence the hotel keeper in this case acts as a simplified interface between multiple subsystems, and the user prevents the user from accessing each subsystem right individually and provides a unified interface. Right? I just have a few questions here. So it only passes the information or executes something on behalf of the requesting process. So it depends upon the way you have implemented the pattern, the object. If you want the facade object to even execute something on behalf of the client who is accessing the facade object, you need to implement that in the facade object as well. Right? Depends upon how you carry out the implementation of that particular object. Right? Actually, it's a structural pattern that we are proposing, that if you have certain objects, some subsystems which are, you have multiple subsystems in your system, and the client is required to access all these multiple systems one by one. Instead of that, provide a facade object which helps the client to access or to modify the chosen case may be the subsystems through a unified interface. That's the idea. This is another question. Can the hotel manager take the order and arrange the food from different hotels and provide room service for the food order? So again, that depends upon how you implement your facade pattern, right? How you implement that particular object. If you want to implement it in this way that even places the order for you and provides you service, right? Otherwise, it gives you a menu and then you can choose, or so manually there you choose whichever restaurant you want to visit and then you go to the corresponding restaurant. If it's manually there, maybe you want it to be delivered at your place, or maybe you want it to be delivered in your room, then upon the implementation of the object, the same would be done. Okay, another question. This looks tightly coupled with the number of types of restaurants. So if you have more restaurants that are adding up, so again these restaurants, all of them will implement the same method, the interface restaurant, and provide implementation for the get menus. The hotel keeper will add implementation to get instances of the new restaurants that have been added, get the menus for those interfaces for those restaurants based on the get menu interface, and add them there to its list. This question, facade pattern is only for one object. We can't need logic in facade since it's just an interface. No, it is just not an interface. It is a subsystem that you would create to be placed on top of multiple subsystems. Since it is required to in each number of subsystems, there will be a large number of methods that would be there in the facade object that you create. So it is not a single interface, right? But the idea is whenever you have to create a facade pattern, your subsystems must implement the same interface, right? And if you would have gone through the previous lecture slide, you would have found the discuss there. We could discuss in the lecture, but it mentions in the slides that code for an interface, right? So in case all our subsystems are actually designed in this way that all of them code for an interface, it becomes easier it becomes easier to implement the facade pattern on it. So in case each of the subsystem initially implements an interface, then you can actually easily make of this object on top of them, right? If the object is working as a mediator for clients, could be considered as that way. There's one question that was asked in the previous also, and would be a good question to be asked today as well, is that why do we always go to an interface and not provide abstract classes for implementation, right? So all these patterns, if you see, it's always said that we provide common interface, right? And every other class in that interface. So why don't we use an abstract class instead of an interface, right? The answer to this is in Java, you can implement n number of interfaces, but extend only one class. However, you can implement n number of interfaces, but you can extend only one class. Now, if we ask you to in an interface, we convert it into an abstract class, right? Then my new creating would be required to extend that particular class. And additionally, if I want that particular class to implement to extend another class, then you will not be able to do it. Right? So only one possible class that you can end, right? Therefore, you do fill that one particular space that is there for extended classes. That is why it is always that you say that all the objects which have a common interface should implement an interface instead of saying that they should extend an abstract class. Right? This is clear, right? Because we have only one slot for extending a class, and the class that I am going to write might be expected to implement another set of might be required to extend another particular. So I'm not filling that slot by asking that particular class to extend the specified abstract class. Right? So that is the reason we always say that it should implement this particular interface. Right? So because there are n number of slots for implementing the interfaces. Right? I myself clear. Okay, that's it I have for the Façade pattern. Let's move to the next pattern. Next design pattern for today is the composite pattern. Right? Composite pattern is also a structural design pattern. The composite pattern is objects into a tree structure, part or whole hierarchies. Right? So this pattern to the individual objects or something called atomic objects and their positions. Right? There might be individual objects or might be composite objects. These composite objects are also made up of individual objects. Right? The idea is that this pattern enables clients to treat the individual or atomic objects and composite objects, which are made out of these objects, in the same manner. Let's understand this with an example. For example, control organization hierarchy. That is a CEO, the head of the organization, right? CEO has, say, general managers working under him who are directly reporting to him. Okay. So the general managers have managers who are working under them. Right? The hierarchy. There are CEO, the manager, the manager. Right? The manager further has clerks work under him, right? Who directly report to him. This has personal assistants who are under the CEO or general manager. So we might have, say for example, a structure like this. CEO, there are general manager, there's a general manager here, there's a general manager. This particular general manager has a manager working under him. The has two clerks under him. This manager has one clerk also working under him, and so also has a clerk working. Has another general manager, and this general manager in turn has clerk. Right? Important notice here is that each of the objects, whether they are clerks, whether they're general managers, their manager or CEO, each one of them is an employee of the company and by the rules of the company. More in this case, if we see, this is the atomic object, right? It is a single atomic object of type employee, right? And it does not further as objects which are which post within it, right? As a general manager here is a composite object. This of for objects which are inside it. The objects which are inside this general manager could be the composite objects or atomic objects, right? For this manager is also an object which is a composite object, right? Just because he has further atomic objects placed inside him. Right? This is a kind of a whole hierarchy where you find objects and composite objects placed within each other. Right? The atomic objects always form the leaves of the tree. Right? Forms a tree-like structure. Atomic objects or individual objects which do not consist of further objects, they always form the leaves of the tree, right? Where the middle nodes are made up of composite objects, right? However, it is important that each one of them is the employee of the company and is governed by the rules of the company. Is we want a pattern so that we are able to access each of the objects, whether composite or atomic, through a common interface, right? So let's see the problem that composite object aims to solve. How to treat a group or structure of objects in the same way as a non-composite object, right? So you want an implementation so that if it is either a composite object or a non-composite object, you are able to treat it in the same manner using the same interface. If the composite and atomic objects so that they implement the same interface, right? Again, here we find that the idea is both the composite objects and the atomic objects implement the same interface. Once able to implement the same interface, the client will be able to access the atomic object and the composite object using the same interface, right? And this is what we have been saying in most of the design patterns that we have seen, that we wait for a unified interface and simply change the kind of implementation it does or maybe the way it is created, right? The whole idea is code one interface, right? Makes the things much simpler, right? Once you are coding for a single interface, the interface becomes unified and you're able to access the objects through the common interface, right? Back to our example and let's try and implement it. Before that, so my composite pattern consists of 4 participants, right? I'll just show you the diagram of the composite pattern. This component, right, which is interface. And this your base component, which is the interface, which all the atomic object as well as the composite object are required to implement. Then there are leaf components, which are your leaf of the tree, which are the atomic objects, right? These components also implement the base component. Similarly, there is composite component. Each composite component also implements the base component, right? Additionally, the composite component also has methods to act instead of the base component, right? Because it's a composite object, it can either comprise of composite objects or atomic objects, right? I saw in the previous diagram at the general manager level, the general manager had a manager working under him as well as a clerk who will be reporting to him, right? So that general manager, who is my composite object, comprise another composite object as well as another atomic, right? So in order to make that possible, I am include objects inside the composite object which implement the component interface, right? It will become more clear as I'll go to the implementation, and then we can come back to this particular structure and see it again. My has 4 participants, right? The first participant is the component or the base component. It is base interface for all the atomic as well as the composite objects, right? So my base interface is implemented by the atomic as well as composite objects. Component is the one which is the atomic object, and this forms the leaves of the tree. So implements the base component and it presents the atomic object, and importantly, it does not contain a reference to other objects, and that is the reason it is an atomic object. It does not compose in itself other object implement the base component, right? The third important participant in composite pattern is the component, right? So this composite component which consists of leaf elements as well as other composite elements. I've just written leaf elements. I will like this. It can consist of other composite elements as well, right? It also implements the base component, and additionally, it provides other operands in order to be able to access the components which are within itself. Right? It provides various child-related operations. It is my class participant. This is able to manipulate the entire tree using the base component interface. Right? This was the structure. Let's see an implementation of this pattern, and then we'll be able to understand it in a much better manner. So I've provided the implementation for the same tree that I had just shown you. I'll just go back to the tree once again. So this is the structure I'm referring to as implementation for this, right? So there is employee interface, and each of these implement the employee interface. I can hand raised, so in case you have any question, you need to type in into the chat. I cannot unmute that. Okay, to implementation, my base component. This is my implementation of the base component. My base component is an interface. The operations which tells the required operations that must be implemented by every atomic object or composite object that is the base component, right? So in this case, since we said that every atomic object or a composite object is employee of the company, so the interface, and it is governed by the rules of the company. So in this case, for us, the interface of the rule of the company is that show employee details. Right? One particular operation is one should be implemented by each of the atomic as well as the composite object. This is let's head to the component. When we say a leaf component, so my leaf component is the atomic object, right, which forms the leaf of the tree. In this case was a clerk, right? So lowest level was the clerk. The clerk implements the base object, right? It implements the employee. Right? If you see here, it provides implementation for the method which is there in the employee interface. So this is implementation for the show employee details. What are employee details? It does, it prints out the employee ID and the employee name, right? Okay. Additionally, this class also has two methods. The employee also has two attributes, which is the employee name and employee ID. It also provides implementation for the structure of class, which takes in strings employee ID and employee name, right? Binds it to the value of the incoming parameters to the attributes of the class, right? My list, which is the database, right? Coming to component. So this composite component name manager. Okay, this composite component employee, right? And if we here, if we this right, since it is a composite component, it consists of a list of employees. Say a composite component has to provide some way to post or to add objects within it. For that reason, it implements, it makes an array list when objects which implement employee can be added, right? And additionally, provides two methods: add employee and remove employee, right? When you say add employee, it adds an employee to this employee list. Remove employee, it removes the employee, which is part of the parameter from this employee list, right? Back to the implementation of our original method, which are in the employee interface, we show employee details. So in this case, the composite object also provides implementation for the show employee details. Because in that, it print out the employee ID and employee name. And additionally, it prints or it invokes the same show employee details method for the object inside which compose this composite object. Here again, so a show employee details method, which is implemented by my composite class, which is manager in this case, first printouts at first provide same implementation as the atomic object class was doing, and it looks over all the objects that is composed of and invokes the show employee method, employee details method for those objects which are a part or which are inside this particular composite component, right? Similarly, you can have more of composite components. You can well have more type of leaf components, right? So in this case, we had only one type of leaf component, which was clerk. So I entered only one class, which was clerk, you have another leaf component, that you would add more leaf components. For composite components, in this case, we have in fact, three composite components, right? So there's a manager who is composite component. Actually, there's a general manager who's a composite component. And on the most level, there is a CEO who is another composite component, right? But all these composite components or atomic components, each of them is supposed to implement the big component interface, which is the employee. Okay. I'll take you to the implementation of the general manager class. So implement the employee in this, right? And the rest of it is all same, right? It has to compose within itself, and it provides implementation for show employee details, implementation for add employee, and provides implementation for remove employee. Now, the last participant that would be there in a composite pattern is the client who would be using it. Right? So the particular client, what it does is that it creates class objects. So they are by individual or atomic objects. The objects are created, right? The aim is to let's go back to the pattern, to the structure. So what I'm doing is that I'm not providing implementation for the whole of it. I'm just working with this much hierarchy. Sorry. With this part of the tree is what we are composing, right? So you need DEO composite object also if you want to extend it to this particular implementation, the entire tree. I'm just working with this tree. I'm got implementation here wherein I'm showing how to create this particular part of the tree, right? Okay. To the client. Let's see what the client participant is doing. Okay. Client is creating 3 atomic objects which are clerks, right? Then general manager, right? Remember, the general manager had a manager inside it and a clerk who has a personal assistant. So this general manager, I add clerk 1, right? Employee. Another manager, right? And this manager had 2 clerks inside it, right? So clerk 2 and clerk 3 should be clerk 3. So clerk 2 and clerk 3 are added to this particular manager. This M1 is now added to the general manager, GM1. So the entire composite tree created, and then you invoke general manager dot show employee details, right? So it will access and play the details of all the composite objects as well. Right? And even invoke show employee details, so it will display the details of M1 and the is composed of. You can invoke one dot show employee details. You can even invoke clerk 2 dot show employee details, right? So the same interface can be used on composite object as well as on the atomic objects. All the atomic objects are joined together to form the composite objects, but all of them together can be accessed using the same interface. I think for the pattern, a few questions. Implementation of patterns, do we need to write complete code or pseudo code enough? In case you would be asked to write the code, pseudo code is enough, right? So do not go for any language specific that we might be looking for, but in case there are, then pseudo code will also do. Composite component, within composite component, I don't really get the question, but if in case composite component, composite component, atomic component, both are possible, because you included an array list which takes objects which implement the base component, right? So that could be either composite objects or atomic objects. Both can be added to that array list. Both of them implement the same interface. See, composite component which invokes GM, which is a composite component. So we do not say which invokes GM, but composite CEO is a composite component which comprises of another composite component, which is a general manager. Right? General employee interface as well as the manager would be a composite component which would implement interface. I think most of this understood. We will take 5 minutes break here and we'll come back with 2 more patterns.